Welcome to the session on loops. So within this section, we will learn about loops. So loops is a very foundational concept within any programming language. You go with Java, C++, or any language you go with, loops are very fundamental to the programming languages. It helps us execute a set or block of code in a repeated manner. So there are different ways by which we can execute this in a repeated manner. So we have two different type of loops present within Python, for loop and while loop. So let's get first started with the for loop, which is the most widely used looping structure present within the Python. So for loop is usually used to iterate over different type of sequences within Python. Now, sequences are something which we will learn in more detail within further sessions, but sequences like list, tuple, dictionary, set. So all of these are like different type of, even these strings are the different type of sequences. Strings to some level we have seen. List to a very high level we will have a look here. But in the next session we will get more detail into this sequences. So let's just have a quick look at the list. List is basically defined as, let's say we have a set of numbers or names. Okay, names like Charlie, John, or even Ramesh, Kiran, any kind of it. So these are like sequence of data. Okay, this is a sequence of data. We can even say age is, let's say Charlie is 20 years, 25 years is John, Ramesh is 18 years, and Kiran is 25 years. So list basically helps us to store this sequence of data. We will get more detail into this, but now for loops, it is important. So the structure of for loop looks like this. For variable in sequence statements. Okay, let's say statement one, statement two. What really happens here is this statement one and statement two will be repeated for every value present within the sequences. So in our case, let's say name. Name has four different values. So the statement one and two would be executed four times, okay, as a input. But variable here plays an important role. So what happens is every value from the sequence one by one will be given to variable, and then this variable we can operate on. Let's take a quick example. We are saying that let's say as a teacher you just want to call out all the names of the teachers. So what will happen here is we are saying for student in names print student. What really happens here is if we run this, okay, we have an issue. This is always the case. Okay, we run it, see always the name is this error here to identify the issue. So here we see that every single name is written in a new line. But if I try to add something additional, the student, like if you're calling the students, students will one by one say whether they are present or not. Okay, so like that, we can say run code and everyone is saying present because we added the present in this situation for all of them. So as you can see, present is printed with every single student here. This means this one by one values were picked up from this for loop and executed line by line. Okay, so like this, we can do different type of operations. If we inside this, we can check if the student is present, and then we can mark the attendance for that. So this operations of students that we can do one by one is what this for loops are for. Okay, so usually for loops are also used to iterate through the numbers and do any kind of operations you want to do. Okay. For example, the age which we have, we can say that for age in age, we will just rename it to ages. Okay, so that we can use age as a variable value. So as you know, one by one values from ages will be given to age. If we go inside, we print age, and we can say if age is greater than 18, then print allowed to enter. Okay, we can also put else not allowed to enter. Okay, so if we run this, so here as the 18 is coming as not allowed to enter because this is not greater than 18. That's why we see this. So that's how the for loops really work. We can do operations on one by one data that is present within the list, and we can operate. In the same way, you can imagine from the database, we can pull the data as row by row, and we can iterate through each row and do any kind of operations on those. Okay, we just saw the examples with how the students it can iterate. It can iterate through the numbers also here. Now let's look at the other version of the loops, which is while loops. So while loops have this structure where it is while, condition, and statements. So here, while waits for the condition to become false to exit. If the condition stays true, it will keep on executing the statement. This set of statements which will be there will be kept on repeating till the condition becomes false. Okay, so here we do not know how many iterations this should go till we have this condition becoming mismatched. In case of for loops, we get to know that okay, this for loop is executing for the number of values that is present within the given sequence. But in case of while loop, as there is no fixed number of statements that it will be executing because it all depends on when this condition will become false. Let's see an example. So imagine we are just simply creating a game, and within that game the points are kept on decreasing. Okay, it's like you have 5 lives, and if your lives are like you're becoming dead in the game and your lives are decreasing, once you have all the lives reduced, it's a game over. So let's try to implement that. Life points equal to 5. Okay, while life points is greater than 0 or not equal to 0, anything is fine here. We can say print you have still lives pending. Okay, and then we will do is life points is equal to life points minus 1. And at the end, outside this loop, we can say game over. Because this loop will only come outside of this loop once all the lives are exhausted. So if we run this, you see that 5 times it is trying to say you have still lives pending. And once all of those lives are exhausted, we are getting game over. Okay, we can even print here, print the life points. So this will tell us that, okay, what is the life points which are remaining. We can still do better operations with the string, which we will learn further once we go to the sequences to learn what all things we can do with the strings. But right now, as you can see, we have this life reducing, and at the end, we see a game over. So this is how while loop can be used in different contexts. For example, let's say you are pulling data from some files, and you keep on reading it till there is still some data. Once the data is exhausted, you stop. Like that, we have scenarios where till this condition becomes true or till this condition becomes false, we keep on repeating this loop. Now, let's also look at some control statements within loop. Like, how do we control the loops? Like, sometimes we want to abruptly stop this loop. We don't want to execute the loops and we want to stop. Or let's say we want to just skip certain values from the loop. So in those situations, we have certain additional features. So control statements, we have break, continue, and pass. So break is usually used to stop the loop abruptly if certain condition happens. Let's say we are creating a searching the numbers program, like search a given number. So if we have a sequence of numbers that is 10, 20, 56, 70, uh, 23, 12. So here, let's say we are creating a loop which is for num in nums. If, like, we will also create a search number. Let's say we want to search for 70. We are saying if search num is equal to the num, print number found, and we say break. Okay, so let's see what will happen. We also print the num in this case. So if we run this, let's also add a statement which says that we are out of loop. Okay, let's run this. Okay, there is an issue. What is the issue? Issue is we missed the dot with the comma. Okay, I just immediately check the error here, which says that okay, this is the place where the error is present. We run it again, and we see that there were 23 and 12 still pending, but the moment 70 was available, this loop came out, number found, and out of loop. Now let's try to look for a number which is not at all present here, 100. And if we run this now, we see that it got till the end, but it did not come out till the end. So that's how like break can help us get out of the loop when we have like certain conditions met, we can get out. Let's have a look at the continue. Now, continue, as I mentioned, is used to like skip certain values in your operations. Like let's say you have a list of employees that you want to go one by one and allocate them some work. Okay, like all the company employees, you are allocating some work, but you are the HR person and you are allocating this work. So you don't want to include any HRs in that. So as you're going through all the employees, you can check if it is an HR, do not allocate, just continue and go to the next person. If it is an HR, skip HR and go to the next person. So like that, continue is useful to not break, but just skip certain elements out of the given data. So let's say a simple example, we want to, let's say again, the same nums we can use. And from this nums, let's say we want to skip the odd numbers. Okay, if any number is odd, we don't want to do any kind of operation and we want to skip. So for num in nums, if the number modulus 2 is equal to 1, basically this means when we're dividing this number by 2, the remainder is 1. So if we divide an even number by 2, the remainder will be 0. And if we divide an odd number by 2, the remainder will be 1. That's how this will be. So we can say print odd number found. Okay. And we can just say not the print here. Uh, so if we see, like we can do the print at the outside. Like we can just print the number. And we are saying if it is odd number, just continue. Now let's see what will happen. If you run this code, what really happened here is if you check 23 is odd in this whole sequence. Only for 23 it says that odd number found, and it did not print this 23 because it just returned to the next number from this step itself. It did the step, and after this step it did not go to the next one but simply went back to the loop and the next number. Like this, using continue, we can skip certain numbers which may meet some conditions and we don't want to do any processing for those numbers. Okay, the last one would be the pass statement. Okay, pass is used not just with the loops but also with the if else conditions. Pass is simply to say that we don't want to do anything right now. These are placeholders. Now, placeholder mean they are just there to take some space, but they don't do any kind of operation. For example, if I have some logic for, but I don't want to do it right now. I just want to go ahead and do the other coding, but I just want to keep for to be here. Let's say 10, 20, 30. Okay, these are just some numbers, but I don't want to do any kind of operation. I just say pass. Okay, and then I can go ahead and do other activities. Okay, so this when we do it, for will not do anything, but will do go to the other activities. Because I'm keeping a for because I have something in my mind for, but I don't want to implement it right now. But I want to say to my future self that okay, this is what I need to implement. If I don't keep a pass, what would happen is it will give me an error because anything after this colon has to be some data. So that's why this is giving an error to me. Just one more concept to understand is loops can also be nested. Okay, loops can also be nested, means we can have a loop inside a loop. Okay, so loop inside a loop would look like this. Let's say like you want to print every possible name combinations, or you want to just identify a map one student with every student of other class. So like class 1, we have student 1, student 2. Okay, and then class 2, we have student 2, sorry, student 3, and student 4. So what this really means is there are two students in each class, and we want to map them with each other every time. Like student 1 would be mapped with 3 and 4, and student 2 have to map with 3 and 4. Like this, when you have 100 combinations, doing this would be difficult. So we can say for student in class 1, for we will call it student 1 because it's from the, or we can even make it a better name is student class 1, student class 2 in class 2, print student class 1, student class 2. So what would happen here is, oh, let me just start the kernel again. So let's run this and see what will happen now. So we see that every possible student combination is mapped. Student 1 with 3, student 1 with 4, student 2 with 3, and student 2 with 4. That's how this for loop with nested structures can work. These are very useful when you have multiple sequences data and you want to go through each of those one by one. Okay, so this is how we can have the nested loops. Thank you very much for watching this session.